Today's lesson is from 1.2, talking about exponents and radicals. Remember, this is just the stuff that we think that you need to review before we head into Chapter 2. So, first we're just going to talk about all the properties for exponents and radicals that you kind of need to refresh your brain on. So I'm just going to briefly go over them and then do some examples using them, so then we can kind of move forward. So, the first one is talking about if you have a base times another base that's the same base and you're multiplying the two together, then you add the exponents. If you divide like bases, then you subtract the exponents. Anytime you have an exponent of 0, that always means that it's 1. Okay? No matter how much is to it, but remember, everything, for it to be 1, it has to have the exponent of 0. If one number or one base has a 0 and the other base does not, then that one base does not, or that doesn't have it, will not change to 1. So make sure you take notice of which ones have that 0 and which ones don't. Okay? Anytime that you have a base to a power which is to another power, so notice that there's no extra base in there, it's a multiplication. Same thing if you have multiple things to a certain power. They all have that power. What's happening there is, remember that these have exponents of 1. So it's like taking n times 1 and n times 1 for the bases of a and b. Okay. Same thing with this fraction, okay, or the quotient. Anytime you take the power to a quotient, both the top or the things in the numerator and the denominator get that power, or multiply their exponents to that power. Anytime you have a negative exponent, that means that you are moving it down. You're not flipping it. Okay? Think about your fractions this way. Okay? Right now, any number or whole number can be written as a fraction, as over 1. Okay? Now, remember that a to the negative nth power is multiplied to 1 technically. Okay, so all you're doing is moving the a down and making the base or the exponent positive, but then that leaves a 1 at the top, and then when you move it to the bottom, 1 times a to the nth is a to the nth. So you're not flipping the whole thing. Okay, you're just moving that particular one down. That's kind of a misconception sometimes. Here for this next one, if you have a fraction here, now notice this one, they both have a negative n because it's to both a and b, so then that one does flip because the a is moving down and the b is moving up. So there is a flipping action there. And same thing with here, because a to the negative nth and b to the negative nth or mth both have a negative, so they both move. So the b moves up to the numerator and the a moves down to the denominator. Okay. Now, one definition you need to remember is that for the nth root. So if you have an n is any positive integer, then the principal nth root of a is defined as the nth root of a, which is equal to some value, whether that be a whole number or a decimal number. Okay, it depends on whether it's a perfect square or a perfect nth power. And you can rewrite that as b to the nth equals a. Those two things match to each other. Now, if n is even, we must have a is greater than 0 and b is greater than or equal to 0. Okay, so that means that both of them need to be 0 or a positive number for it to work in an even power. If it's odd, then that really doesn't matter that much. Okay. Okay, so then some radical properties. If I have the nth root of a times b, because you have multiplication there, just like if you wanted to put them together under the same root, you can separate them and write the nth root of a times the nth root of b. And then, same thing for a quotient. If they're both under the same radical, you can split them apart and make the numerator just over the nth root and the denominator over the nth root. If you have the mth root over the nth root of a, so they're like 2, it's kind of like the exponent problem or property before where you were multiplying, like you have a power to a power. This is the same concept. You have a radical to a radical, so then you can multiply the exponents or the roots together to make the mnth power. So if this m was like 3 and n was 2, then you could get the 6th root in the end. Remember that you can write radicals as rational exponents. So if you have 1 over the m power for a, then that's the same thing as the mth root. If you have the the m divided by n power for a, then the n represents a root and the m represents how many there are, just like the 1 over here represented that there's a 1a. So here you have m a's that are multiplied to each other. Now this one's just to remember that if you have the nth root of a to the nth, so the power and the root are the same, they can cancel out, but you only get a if n is an odd number. So if like it's the cube root of x cubed, then you're reducing that requirement for the root for it to come out of the root because it's a perfect cube. So that leaves you with x. But then if you have like the second root or the square root of a squared, then you can only get the positive one, because remember, you can't have a negative number or negative base underneath a even root, because that would be imaginary. And so that's why they have absolute value signs here. So n has to be even, you can only get the positive. Up here, you can have a negative power down there, and that won't really change anything, okay? Because you'll just have, like, let's say you have the cube root of negative 27 cubed, then the cubes cancel each other out, and you're left with negative 27, so that's okay to have. Okay, so let's do some examples. So example 1, notice that you are multiplying like bases, so a cubed times a to the 5th gets you a to the 3rd plus 5, so it gets you a to the 8th. Okay. Here there's subtraction because you're dividing, so then that means you have b to the 6 minus 4 power, so then that means you have b squared. 6 minus 4 gives you 2. Here for c you have a power to power. Notice that there's nothing else that attaches that 8 other than the parentheses, so that means multiplication. Okay, so then I get x to the 16th. Same thing here. Notice that the 4 goes to both the 3 and to the 2 because the parentheses are around both. So then I have to multiply it just like I did for c. So x squared times 4 and y cubed times 4 gives me x to the 8th and y to the 12th. Okay. Same thing here for quotient. The 10 goes to both the exponent for p and the exponent for n. So then that means I get p to the 10th time 10 power and n to the 2nd times 10th power. So it gives me p to the 100th over n to the 20th. Okay. For f, notice that we're a negative exponent. So remember, it's like over 1, so this is going to move down and it's going to make this negative exponent become positive. It doesn't change the sign of the base, it changes the sign of the exponent. So I just get 1 over x to the 5th. Okay. G has 6x squared y cubed all to the 0 power. Notice that they're all to the 0 power. So that means that they're all going to be multiplied to the 0 power, which makes them 6 to the 0, and x to the 0, y to the 0, so that gives you a answer of 1, since they're all to that. Same thing for h. that's just like if we were doing it for e, for the p to the 10th and n to the 2nd. Okay, so here I want to take my -3 and take it to the 2 and to the 3. Now there's two different ways of doing this. You can do this first, and 2 times -3, and b times 3 to the -3. Okay, that gives you a to the -6 over b to the -9th. And notice that they're both negative, so then that means the b goes up and the a goes down. So you get b to the 9th over a to the 6th. Okay? Now the other way is you could have flipped it and then squared them. So like you could have flipped them on the inside of the parentheses first and made that +3 and then multiplied them, and then you would have gotten to that point as well. So either way is correct. Okay, letter I, you have a radical, so your fourth root. So here we're looking for perfect fourths, or fourth root powers. So 81 is 9 times 9, 3 times 3 times 3 times 3. So you have 3 or 4 threes. So then, since you have 3 to the 4th, then that means that you can take that out and make it 3. X you have to the 8th. So it's almost like division here for ones that you already know the exponents for. So that means I can get 2 groups of x that meet that requirement of the fourth root. So since I get 2 groups, it becomes x squared. And then there's one group for y to the 4th, because of the fourth root, so they cancel each other out, or makes one group. You don't have to write the 1, but just so you know that there's one. Same thing for the 3. There's one group for the 3. Okay. Now here you can use one of your properties, and we could have done it with this one too. You could have split them all up if you like that better. Let's fix those parentheses. And you could have done the same thing to get there. So here, the fourth root of 16 and the fourth root of 81. Fourth root of 16, there's 4 2's in there, so that gives me one group of 2's. And we just said that there are 4 3's in 81, so then it'd be 2/3. Okay, and the last two of this, if I have 125 to the -1/3 root, or power, let's flip that because of the negative exponent first. So move it down. Okay, so now I'm going to change that to a radical because it just makes it a little easier to comprehend what it's talking about. So it's asking me for the cube root of 125 on the bottom. So 3 numbers that multiply to make 125 is going to be 5. So the cube root of 125 is 5. So my overall answer will be 1/5. And then for the last one here, this one will probably be easier if I change it to rational exponent form. So that gives me x times x to the 1/2 power. And then the other one is to the 1/2 power. So now I can use my power property and take them both. And 1/2 times 1/2 gets me 1/4. And so then now 1/2 plus 1/2, or sorry, 1/4 plus 1/2 gets me, make your common denominators, so 2/4, so it gives you 3/4. And that would be my final answer. Okay, have fun.